Hi, this is Leslie, and I'm going to be trying to visualize the magnetic field created by an electromagnet. The supplies you need are listed right here. Here is everything I mentioned. We got our nails of different sizes, we got our electrical tape, our duct tape, our pencils, our big battery, optional, our wire cutter, our measuring tape, our D-cell batteries, our wire itself, and these are the iron filings. And ignore this because this is just measurements for me to take the video. Oh, and one other thing I forgot to mention, it's distilled white vinegar. I'm going to try to preserve the image afterwards. And if you're going to be dealing with rusty iron nails, like I might be, and I already poked myself, you might want to make sure you have your tetanus shot. All right, I'm going to get started. Okay, so the first thing I'm going to do is measure my wire. I'm going to put a mark at 6 inches and a mark at 1.5 inches. I'm going to strip the wire from here down, and this is where I'm going to start winding the wire around the nail. So I'm going to go strip that. Okay, so I stripped the wire right here. I didn't strip it yet. I just did the insulation, and that should slip off, hopefully. A little muscle. I'm probably going to knock everything over. There we go. All right, so that's stripped. I'm going to twist it, make it nice and together so we can get a good contact on our battery. And I'm going to give it a little bend. All right, so now I'm going to start wrapping my nail, and I'm going to use this small one first. I actually already wrapped it and everything, but I have a straighter nail, so I'm going to use that one, but just kind of show you what I did. So at the 6-inch mark that we marked, I'm going to start wrapping, and we're going to go in the same direction, nice and tight. In fact, it's good to start on a thinner nail than a thicker one, because you can wrap it on the thin one, then pull it off that one, and it'll be nice and tight on the little bit thicker one. So anyway, you keep wrapping it all the way down to the end. And that is what I did here. I had to use, this is why the electrical tape was on the supplies needed, because this would not stay. So I'm hoping that's not going to affect my experiment. Here it is, all done. We've got the nail, 6 inches, 6 inches, and the little ends a little bit folded and stripped. All right, on to the next thing. Oh, and also should be a wooden table, okay? So now what I'm going to do is I'm going to duct tape these two D-cell batteries together, have the positive end exposed on one side, and we're going to do it like this. So it's going to be positive, negative end, positive end, negative end. So it's going to be like one big battery. So that's the batteries duct taped together. I'm going to take the 2 pencils, line them up with my markers that I made. Little red marks. Hopefully the metal on the pencil won't matter. And I'm going to lay my paper over. I've already realized something, that I wished I had made those longer than 6 inches, but I'm going to cut my paper and we'll work with it. Okay, so I've decided to tape my pencils down ahead of time after I laid it out the way I liked it. I also decided to tape the battery down, and this is centered where I like it, for the camera mainly, and it reaches, which is good. And I did put a piece of tape here, which you can't really see, but when the paper goes on top, that will line up where this goes. So one last thing is, I think I might quickly tape those sides too. Okay, so I taped those. All right, here's our paper. That's a little bit smaller than it originally was. And I used my center mark up here where the coil is. So that way, hopefully, this will come out on center. So, theory goes, I should be able to get a current running through the wire, negative to positive, and put iron filings on the paper, and hopefully it will create a pattern around the electromagnet. Okay, so this is the first time I'm ever doing this, so I'm not even sure how many iron filings I should go with, but let's see. I already taped the negative side on, but I haven't completed the circuit. This might be way too many. We'll see. Here we go. Alright, obviously I have way too many filings. I'm going to do this. Let's see how that works. So this gets really hot, I realized also. So there we go. If I shake it a little, you get to see the magnetic field building up. It gets really hot. Okay, well that's pretty cool. So it looks like there's two fields here. Unless this is the field out here that you just can't see. Let me add some on the outside. Alright, I was playing around a little with it, and you can kind of see how some of the filings are going that way. I think some of these filings might just be too heavy. Oh yeah, look at it. It's definitely forming. You can see the waves, the field I should say. The side's a little heavier on the iron. Alright, let's see if this helps. Okay, now what I'm going to do is not start a fire, because that's super hot. I'm going to spray that with the vinegar, the mist, and hopefully we will get a cool picture. I decided a little, sort of a kid's paintbrush was good just to sort of get it lightly spread it out, just so it doesn't have too many clumps in one place. Okay, now if you notice, this is now 3 D-cell batteries. We'll see what happens when we do this. Alright, there we go. You can really see it. I don't want to tap it too much, but that is really neat. Whoa, and it's smoking. Okay, I'm going to try the 3 D-cells again, and I'm using much less filings. Don't use a lot of lead filings. There you go. Can you see that? Fields, magnetic fields right there. Okay, so I have one last thing I'm going to do. I'm using the bigger nail, same wire, same amount of coils, 3 D batteries like before. Yep, well, let's see, what's the difference between the big nail? Just that the poles are further apart. And that's probably the main difference, because the coil is the same length and the wire is the same size. The only thing difference really is the length of the nail, the diameter of the nail. So I'd say that's mainly the difference. A couple things I learned about this is tape your things down. You can tape this ahead of time. This electrical tape doesn't seem to bother anything, so that's good. Go very light on your iron, very, very light. It works better. You can see it much better. So I just wanted to say what I think is going on here is the wire is carrying a direct current, and the wires that are carrying direct current are surrounded by a magnetic field. And when an electric current flows through this coil of wire, the whole coil acts like a magnet with the mainly iron nail, and we created an electromagnet. And winding the wire into a coil increased the strength of the magnetic field around the electromagnet. So the iron nail became magnetized by the magnetic field around the wire, adding to the strength of the electromagnet. The iron filings, they get attracted by the electromagnetic force, and they line up in the directions of the magnetic fields. And the paper shows the magnetic field. And I sprayed white distilled vinegar on the paper, and I will let you guys see the results of that. It takes several hours, I'm guessing, for the iron to rust onto the paper. Alright, so here's the first one. When I used a little too many iron filings, and I sprayed the vinegar on and it rusted the iron, and then I scraped that off, and that's what I was left with. So that's the first one. Here's the second one, the one with the much lighter filings. That's zoomed in a little bit. And I played around, I scanned them, and I played with some colors, so I'll show you those two. Alright, so that's the lighter one. And that's the first one with some green. Okay, so this is after I colorized them and then inverted them. And actually, I guess it's really not upside down or right side up, but the poles are still going this way on each one. Hope you enjoyed the little experiment of visualizing magnetic fields by creating an electromagnet.